Hi everybody, welcome to the class Optical Communication, Unit 2, Transmission Characteristics of Optical Fiber. In a previous session, we have seen about scattering losses. So what are the two major factors that causes scattering loss in your optical fiber and what are the types of scattering losses? Under types we have seen linear and non-linear scattering. Under linear scattering, there are two types, Rayleigh and May scattering. And of course, today's class, we are going to see about bending losses. So these are the major mechanism that causes attenuation in your optical fiber. We can name the bending loss as a radiative loss. There are two bends, one is microscopic bend, other one is macroscopic bends. So let us see what is the radiative loss, how it occurs. The radiative losses occur whenever an optical fiber undergoes a bend of finite radius of curvature. As we have discussed earlier, fiber can be subjected to two types of bends, microscopic bends and macroscopic bends. Let us see the short definition for macrobending and microbending. Macrobending, light lost from the optical core due to macroscopic effects such as tight bends being induced in the fiber itself. Microbending, light lost from the optical core due to microscopic effects resulting from deformation and damage to the core cladding interface. Now in detail we are going to see about macro bending. Normally in slight bends the losses are unobservable. By decreasing the radius of curvature we will come to the critical value after which this losses increase drastically. As shown in the picture, when I am bending a fiber to a very critical value of radius of curvature, the losses will increase drastically. Okay. As we know that electric or a magnetic field have a tail in the cladding region. So, by bending the cable, we come to extent where cladding field should move faster to keep up with the core field. Of course, practically this is not possible. So, what will happen? The energy in the cladding region radiates away. So radiation loss mainly depends on the value of Xc and the radius of curvature capital R. As we all know, your lower order modes will remain close to the core axis and your higher order modes remain close to the cladding regions. So when bending the fiber, the higher order modes will radiate out of the fiber first. The macro bending losses are commonly occurred or normally produced by poor handling of fiber. Okay. So during installation, poor reeling or a mishandling of the fiber can create severe bending of the fiber, resulting in small but important localized losses. So this is the figure that depicts the poor reeling. So here you can see in the fiber bends, there is a bend in your optical fiber that leads to the macro bending loss. So this is a minimum safe bend radius to avoid losses in your optical fiber. At least we have to maintain 100 mm diameter to reduce the losses. So when we are further bending the fiber, your losses will get increased. So this three diagram that shows the first one that causes 1 dB loss and second bending causes 4 dB loss. And of course, if your bending is very small, that leads to broken the fiber. That leads to damage your fiber. So this is about macro bending losses. Next one is a micro bending losses. It is a radiation loss in optical waveguide results from mode coupling by random microbends. Fiber curvature causes repetitive coupling of energy between the guided modes and the leaky or the non-guided modes in the fiber. Microbending is much more critical feature and can be a major cause of cable attenuation. So these stress are very difficult to define. However, they can be caused by non-uniformities in the manufacturing of the fiber, non-uniform lateral pressures during cabling, lower temperature, and of course due to high pressures. So this is a figure that shows the micro bending. So if there is a micro bending or inhomogeneity in your fiber material structure, that leads to the power loss in your optical fiber. So how to reduce the micro bending loss? So for that we have to use a compressible jacket. So a compressible jacket extruded over a fiber reduces micro bending resulting from external forces. So in this diagram clearly shows when a pressure is applied to your fiber, to your bare fiber, of course there will be a micro bending losses. So when we are using the compressible jacket, we can reduce the losses and we can increase your power. We can use the bending losses for various purpose. First one, fiber optic pressure sensor and active fiber detectors. This both can use the bending losses. So there are many uses of bending losses which are based on either the increase in the attenuation or on making use of the light which escapes from the optical fiber. Of course, a pressure sensor that make use of the increased attenuation experienced by the fiber as it bends, and your fiber detector will use as the escaping light. So this is about the short introduction, about a short summary of your microbending losses. So we can use the photocell when the losses occur in your fiber. So when I am placing an active fiber when I'm placing active fiber, when I'm using active fiber for an applications, when I'm placing a photocell, so that will produce a beep sign if more pressure is applied to your fiber. So that's it. So till now we have discussed what is mean by attenuation, what are the three major mechanisms that causes attenuation. In today's class in detail we have seen what is the bending loss and what are the two types of bending losses, how to reduce the loss. Thank you.